Hello everyone. So in the last episode, we went ahead and established our history states, and they are able to capture all of the data at any given point in the visual novel. So now let's implement the history manager, which will allow us to recall those states and reapply them. So let's actually start in our testing script. Let's make sure that our testing script has access to create history states and that we can recall them. So let's replace all of this with a history state. So public history state state equals new history state, and then update if input.get key down keycode.h, then state equals history state dot capture. So we'll capture the current state. So as we come in here, if I hit H, then we can see that I get the characters, I get the audio, and the graphics. And everything looks good. Now, how about when I recall? If input, what is that? If input.getKeyCode R, then I want to be able to recall that state. So I'd like to be able to do something like state.load. And then we will go ahead and load the history state. We've already defined that function, but we haven't given it any content. So let's do that now. State.load is going to look at all of this data, and it's going to apply it back to the screen. So we will go ahead and say dialog.apply, and as well as characters.apply, and audio.apply, then graphics.apply. None of those functions exist yet, so let's start with our dialog. Let's go to the dialog data, and then let's make a public void called apply. And this will reassign everything back to the screen. So we sucked it all in, now it's time to spit it back out. First thing we can do is we can go ahead and grab our dialog and name text like we did before, because we're going to just put it right back to those objects. So let's go ahead and say that dialog text.text equals the dialog equals the current dialog. Okay, so we grab that. Let's also get the color. Dialog text dot color equals dialog color. Dialog text dot font size equals dialog scale. And we'll do the same thing for the name text, so copy that, paste, and just change this to name text.text, name text color, and font size. And then we'll say speaker, or current speaker, so current speaker right there, then speaker color, and speaker scale. Now we also need to reload the fonts. And the way that we're going to do this with the history system, rather than going through resources, because think of if we have 100 of these history states and we're going back through them a lot. For fonts, graphics, audio, we don't want to be reloading everything back from resources on every given check. So we could go in and compare the names, but then we would also need to see if there's a difference, and if there is, we'll be using resources.load, and we'll be doing that over and over again. So instead, how about we create a cache just for our history that's going to keep track of all the items that we load, so that way, as we navigate from point to point and state to state, it can just go ahead and reload these things from cache instead of having to pull them from resources and use more system memory. So we can make a new script and compile it. I'm going to comment these sections out and just leave dialog.apply. So in Unity, let's make another script called history cache. The history cache is going to contain a dictionary of references to objects that we can reload at real time. So we'll make everything static, that way we can access it at any point. So public static dictionary, and we'll make the key the name or the path of the item that we want to reload. And then we'll make an object as the key. But in the event that we have many things loaded in here, we might want to do some history cleanup. So I'll also pair the object with an index that we can, increment and figure out how long it's been since this thing was last accessed. And then we'll just remove old stale ones. So we'll make an object, and we'll also make an integer. So the object is going to be the asset, and the integer is going to be the stale index, which we can just increment over time. Or we could swap that out for a time date and just evaluate by how long it's actually been in real time. But I'll stick with this for now and just call this loaded assets. That's our dictionary. And this is going to equal a new dictionary. Why are we doing that? I don't want you. I want new dictionary. There we go. A new dictionary of those items. So let's try to grab an item from this dictionary. Because when we're about to reload the fonts for this character, but we don't want to reload them from resources, we want to grab them from this cache. So say we've got the items in here. Let's go ahead and try to load them. Let's see, even if we don't have them, let's just try to see if we can load them. So public static, this is going to be a generic type of t, because we don't know what we're returning. We're just going to try to load an object of type t. And what we're looking for is a string for the key, which represents the ID of this asset. So let's cache first object resource as null. We don't have anything yet, but maybe we will. So if loaded assets dot contains key, and this is going to look for the key that we've passed in as a parameter, then resource equals, let's make sure that we get the loaded assets key, but cast it as the type of t, and get the asset. So we're getting the object and we're casting it to the type of t. If we don't have it in our dictionary, then let's go ahead and grab it from resources and load it that way. So resource equals resources.load, and we're going to load it by the key. So we go ahead and grab it out of resources, and let's just see if it's null or not. If resource equals null, or rather if it's not equal to null, meaning we did find it, then let's go ahead and assign it to our dictionary so we have a reference to it in the future. So loaded assets key equals a new tuple here with our resource as the object, and we'll start off at 0 for our stale index because it's brand spanking new. Now, after we've gotten our resource, which may or may not be null, let's go ahead and see if we can return it. So if resource is not equal to null, then we can do something. Otherwise, if we didn't get a resource, it's not in the dictionary, and we couldn't load it from resources, then return default t. And maybe log a message. So debug.log warning saying could not load assets. So could not load object from cache, followed by whatever that is. So we'll look for the key. However, if we do find it, let's make sure that we've actually got it as a valid type for what we're trying to cast it out as. So if resource is t. If it is t, then we'll go ahead and return resource, but make sure that we cast it as that type. Otherwise, we know that we didn't get anything. We'll say debug.log, or rather not anything, but we did not get it in the right type. So debug.log warning again. And what we're going to say here is retrieved object key was not the expected type. So this will go ahead and load it if it's in our cache, and if it's not, it'll load it from resources and put it in the cache. So let's make some quick hand functions, or shorthand functions rather, if I want to use the right word, to get the different types that we might be loading. So what we're about to do is we're about to load a font. So let's go ahead and do that. Public static tmp font asset load font and string key. What this is going to do, it's going to try to load an object of the tmp font asset type. Some other things we might want to load. We're also going to want to load an audio clip for our audio. So audio clip, and we will call this load audio, passing in a string there, and change TMP font asset for audio clip. Then we also want a texture 2D for load image, and we'll try to load it as a texture 2D. Otherwise, we'll try to get a video clip because we might have a video for a background. So load video and try to get it as the type video clip. Not going to worry about cleanup right now with the stale index. We'll come back to that at a later time. Or you can implement that yourself. Or just stick to the object and don't clear it out, but I wouldn't recommend it. Okay, so when we're applying this, let's go ahead and check and see if we should change the font. So let's see. If dialog font, if the dialog font, what is this? Yeah, so if dialog font is not equal to the dialog text dot font dot name, then we know we need to change the font. So tmp font asset equals history cache dot try or dot load font. We're going to load the font from our dialog font key, which is just the name of the font. And if font asset is not equal to null, then we'll go ahead and say that the dialog text dot font equals the font asset. And we'll do the same thing for our name text. So we'll say name font, or speaker font rather, speaker font is not equal to name text.font.name. Then we get the font asset, load it from the name font, speaker font, getting these things confused. And then we'll say font asset is not null, then name text.font equals the font asset that we just loaded. So that'll reload all of the dialog data on screen. Let's go ahead and do the audio next. So we've captured the audio, now let's apply it. So public void apply. Let's go through every one of the channels in this data and reapply them to our audio manager. So for each, we'll say for each var channel data in, hang on, I just realized we're going to want to make this static because we are running this as a list of audio data, not just the audio data item itself. So public static void apply, and we want to take in the list for the audio data. And this will be, we'll call it data. Okay, so we're going to make it static, which means I'm actually going to come back to audio data, and I'm going to change this to static as well, and move void apply, dialog data. I'm going to pass in the reference and call that data. So for every one of these instances here, I'll now reference data to get the values. So everything's going to be applied statically by referencing the object. That way, when we have lists of items, we can apply them just as easily as if we only have one, just by caching it in. So history state, public void load. We're instead going to say dialog data dot apply and pass in our dialog. And then when we do audio, we're going to say audio data dot apply and pass in the list of the audio datas. So now we can go through each channel or each data instance. Since the audio data represents a channel, we want to go through every item in this list. So for each var channel data in data, every item, let's go ahead and grab the channel. Audio channel equals audio manager dot instance dot try get channel, and we'll pass it in as the channel data dot channel. That's the channel we want to load. And create if does not exist, we want to set this to true. We want to set it to true because if we reload this at a later time and the channel doesn't exist, it's still a valid state. We just need to reapply the channel. So we need to create it if it's not there. Now, let's check and see if there's an active track. If we're able to reload this audio, we want to make sure that there's not an active track or the track is not playing what we're trying to play here. So if channel.activeTrack is null, or channel.activeTrack.name is not equal to channel data.track name, then we know that the saved track is not what is currently playing here, or we just don't have anything playing at all. So let's go ahead and grab the audio clip so we can play it. Audio clip equals, let's get it from our history cache dot load audio, and we're going to load it from our channel data, and we need to load it from the path, the track path. So let's make sure that we actually got something. If clip is not equal to null, then we'll go ahead and say that we want to stop any track that may be playing right now. And with history states, since we're navigating back and forth between them, I don't think I'm going to have any gradual transitions. You don't normally see transitions when you go back in history in visual novels, for those of them that do support history. You just get instant transitions because you've already seen it. There's no need to go through it again. So let's say channel.stopTrack, and let's make sure that we can specify that this needs to happen immediately, because if we just stop the track, then it's going to stop gradually. So let's come in here and say bool immediate will default to false. But if we specify that it should be immediate, then let's destroy it instead. So if immediate, then let's go ahead and destroy this track, destroy the active track on this channel. And then we'll say active track equals null. Otherwise, then we're going to say the active track is null, and we're going to start the volume leveling. We got to set the track to null after we destroy it here, because otherwise we got nothing to destroy, and we want to set it to null before we start volume leveling, because then it knows that this track is inactive, and it'll go ahead and start fading it out. Okay, so we stop the current track and make sure that it is immediate. And now we need to play the new track. So channel.playTrack, and we're going to play the clip and use the same values that we saved into our data. So for loop, we need to get channel data.loop. Was it looping? Then we need to reassign it. And for the volume, the starting volume, we actually want to start this at the max volume, which is going to be the volume or channel data.track volume. And the volume cap, we need to do the same way. Channel data.track volume. This way it starts at the maximum volume and we don't have a transition. Now, as for what we're looking for next, the next thing it wants is the pitch. So channel data.pitch. And then the path. So channel data.track path. All right. And if we didn't get a clip, then we know something went wrong, and I'll log a warning saying the history state could not load the track at that path, and I can go in and check it out. So that will go ahead and start any tracks that were recorded. But what about ones that might have stopped? So if we have a track playing for states 1 through 5, and then at state 6, it stops, and we have a new track start on a different channel, then if we go back to a previous one, steps 1 through 5, they'll only have a reference to the old one, they won't have a reference to the new one, so the new one would keep on playing even when we're going back in history. So we need to stop any ones that are not mentioned inside of this list, which means we need a little internal cache. So list, we'll just make this list a cache of channel indexes. So int, we'll call it cache, equals new list integer. So every time that we create a new channel here, we're going to add it into that cache. So I will say cache.add channel data.channel. And once we exit that loop, now let's cancel any channels that weren't active during this state that might be active now. We can do that with a for each loop var channel in audio manager dot instance dot channels. For each one of these things, we're going to see if it's in the cache. If not, cache dot contains the channel dot value, or the key is actually the index, isn't it? So if it doesn't contain the key, then we'll say channel dot value dot stop track immediate true. I'm caching the channel data channel. They should both be the same, but I'm just going to go ahead and say value dot channel index, since that's what I'm saving directly. That's what I'll reference. But I believe they were saved as the key for the index. Which, yeah, if we look in the audio channel, try get channel, it creates a new channel with the channel number, and then that is the key. So yeah, you could reference the key there. Okay, now for our graphic data, let's reload all the images and videos that were on the screen previously. So let's come all the way down to the bottom here and make a public static void apply, which will take a list of graphic data objects as data. Again, just like we did for the audio, we need to cancel out any ones that aren't mentioned, so we'll make a list for the cache, and we'll just cache the name of each panel, and we'll say cache equals new list string, so we know which ones to cancel out later. Now, for each var panel data in data, let's go through every panel that we just saved. Var panel equals graphic panel manager dot instance dot get panel, and we're going to get the panel by the panel data dot panel name. These panels should already be created inside of the Unity editor, so we don't really need to do a check for that. Should be there. So for each var layer data, let's get every layer in panel data dot layers. Let's go through every single layer and go ahead and grab the actual layer reference. Var layer equals panel dot get layer, and we're going to get it by the layer data, or layer data dot depth. That's the one we want, and create if does not exist to be true. Just like we did for audio, if we have loaded this and we've reloaded it at a time where that layer has not been created yet, let's just go ahead and take care of it and create the layer so we have something to apply the graphic to. Now let's see, can we and should we assign the graphic to this layer? If layer.current graphic equals null, if there's nothing assigned, we know we need to set it. Or layer.current graphic name is not equal to layer data graphic name. If that's the case, then we know we need to set it there too. So let's check and see if what we're working with now that we're going to assign it, see if it's a video or if it's an image. So if not layer data is video, then we are working with an image. Otherwise, we're working with a video. So if we're not working with a video, then let's get a texture. So texture text equals history cache dot load image, and we're going to load it by the layer data dot graphic path. If we have a texture, if text is not equal to null, then we should apply it to the screen. So we'll reference the layer and we'll say set texture, and we're going to set the texture as what we just loaded, and we're also going to specify just the file path. So file path is going to be the layer data dot path, so graphic path. And let's also say immediate will be true, just the same as audio. If that's not the case, what's up with my file path here? Named argument file path specifies a parameter which a positional argument has already been given. That's interesting. So if we look at the graphic layer and look at the set texture methods, we have one that takes a texture and we have one that takes just a file path. Now, one thing I notice is immediate is not being passed into the one that takes a texture. So let's go ahead and pass in immediate there. But that doesn't explain why we are having this issue. Oh, well, actually, that does. So we have lowercase file path, and then we have capital case file path. And I just specified capital, so it set me up with this one. Okay, so how about I change that? Oops. How about I change this to file path? Good lord. There we go. Let's do that again. I don't know if it actually took. Let's do file path. Okay. We should be good now. Let's go back to the graphic data and say that file path is equal to the layer data dot graphic path, and then immediate is true. And it likes it, so we're good. If we don't have a texture, then something went wrong, and let's load a warning saying we couldn't load the image from the path, and we can check it out. So we can do the same thing if it's a video. We just need to get this as a video clip, and say that it is equal to history cache dot load video, and we're going to get it from the layer data dot graphic path. So if our clip is not equal to null, then layer dot set video, and we're going to set our clip, and then we're going to set our file path, which it looks like I did the same thing down below. Yeah, so let me go back to set video, and we have file path capital and file path lowercase. I did not do that on purpose. File path capital case. There we go. Graphic data. Okay, so file path is going to equal the layer data dot graphic path, and then immediate will be true. If that's not the case, then we can go ahead and pass another one, say could not load video from the path. And outside of this for loop for every layer, now we can add it to our cache, this panel. So cache.add panel.panel name. And outside of that loop, now we can go through and disable every panel that was not mentioned here. So for each var panel, not capital, panel in graphic panel manager dot instance dot all panels, if not cache dot contains panel dot panel name, then let's clear it. We're going to clear this by saying panel.clear, and we're also going to specify immediate to be true. And that should restore our graphic data to the screen. Oh, after, I always forget that. Static void. Namespace cannot directly contain members such as fields, methods, or statements. What did I do? Oh, so that message means I stuck this inside of the namespace, which it should not be in there. So let me just go and see where everything else is at. Inside of graphic data, so it should actually be in here, right there. It needs to be inside of the graphic data class. There we go. Now for our history state, I can say graphics dot or graphic data dot apply and pass in the graphics, which means the only thing that's left is the characters. So inside the character script, let's come right down below capture and let's make a new public static void called apply, which will take a list of character data containers, and we'll call it data as well. Again, let's make a cache, which will be a string containing each name of the characters. If a character is not found in this, we will going to hide them. Then let's do a basic for loop to get each character data inside of this list. From there, we need to grab the actual character from our character manager that matches. So character equals character manager dot instance dot get character, and we're going to grab the character data, character data dot character name. I'm hitting enter too fast. Character name and create if does not exist should be true. We need to make sure they're in the scene. So let's just go ahead and apply the information. So character dot display name equals character data dot, come on, almost, you almost had it. Character data display name. And let's do the color. Character dot set color to character data dot color. Next, if the character is highlighted, we need to make sure that we highlight them. If they were unhighlighted, we need to make sure they're unhighlighted. Let's go ahead and set their priority to what was recorded in this state. That way they can sort in the right order. And let's make sure they're facing the right direction. So if they're facing left, call face left and make sure that all of this is running immediately. Let's also make sure we set their position. So we're going to set their position to what was cached in the history state. And we'll set their visibility to if they were enabled or not. And so at this point, what you've got is you have your configuration cache that was saved as well. So if you wanted to, you could convert that into the configuration data and reapply it to your character. I don't particularly see the need for that. The character is not going to have their configuration data change, so it's all going to be on the screen anyway. So if there were different colors or different fonts or different sizes, the dialog data will handle that. But we've got the configuration cached if we need it for something else. So I'm just going to go ahead and proceed on from here and move on to the next thing we need to do. And that's going to be reapplying our JSON data to the different character types. So let's figure out what character type this is and convert its data back to the original format and apply it to the character. So let's do a switch based off of the character data dot based off the character dot config dot character type, and let's check if the case is a sprite character or it is a sprite sheet character. We'll go ahead and convert it and turn it back. Otherwise, we'll get the live 2D character, break, or we'll get the model 3D character, break. Of course, only doing this if you need to for these types, if you're using them. Let's start with sprite sheet. So with the sprite sheet, let's get our sprite data back. So sprite data, s data equals, we've already got the JSON string, so let's just convert it back to the original data type. JSON utility dot from JSON. And what we're going to convert it back to is going to be the sprite data. And what we're converting, of course, is character data dot JSON. So this will get us our data in the original format, and now we need to get our character in the correct type. So character sprite sc equals character as character sprite. All right, so let's go through each one of the layers. I'll do this with a basic for loop to get each layer, and cache that layer into a new variable so we can modify it. Now, in order to determine if we should modify it, it either needs to have no sprite or its sprite can't be the same as what we're trying to apply. So let's go ahead and check if this is correct. So if sc.layers, we're getting the layer straight off of the character, and which one? I, the index that we're working on. If that renderer.sprite is not equal to null, and the sc.layers, let's get the I, if that same renderer.sprite, the name of that sprite, is not equal to our layer.sprite name, then we want to reapply this. So let's grab the sprite. Sprite equals, we need to do sc.getSprite, and we're going to get it from the layer.sprite name. This will do that lookup in the dictionary so we can get the right sprite for the character. So once we've got the sprite, if sprite is not equal to null, then sc sprite character dot set sprite. We're going to set the sprite to what we've just loaded on that layer that we're working with. Otherwise, we'll go ahead and log a message, debug.log warning, saying that history state could not load sprite, and then pass in the layer.sprite name. That's for if we're working with sprite characters. If we're working with live 2D characters, then live 2D data, L2 data, equals JSON utility dot from JSON live 2D data. And we're going to get the character data dot JSON. Okay, so we convert it back to L2 data, and let's go ahead and grab our character in the live 2D format. So let's go ahead and try to see if we can set the expression. If lc.activeExpression is not equal to our L2 data.expression, then lc.setExpression to the L2 data.expression. And we'll do the same thing for the motion. If lc.active or lc.active motion, if that is not equal to L2 data.motion, then lc.setMotion to the L2 data.motion. And there may be more values that we need to set for Live 2D and more values for Model 3D. But we'll work on this for now, and if we need to add more things, we'll do that later. If you know of any things that you need to add for your characters, go ahead and add them in there while we're working on this. Now let's do the Model 3D character. So Model 3D data, m3 data equals JSON.from JSON, converting it to m3 data from JSON m3 data, the character data.json. Wow, I messed that all up, but I fixed it too. Then let's convert our character to the Model 3D, and let's go ahead and set the position to what was cached, and set the rotation of the model to what was cached. And that gives us everything that we need for our characters. So for every character that we do this to, we need to make sure that we add them to the cache. So we'll say cache.add, and we're going to add the character.name. Now, outside of the loop, let's go ahead and hide all the ones that were not recorded. For each character in character manager.instance.characters. Had it right the first time. All characters. For each one of them, if not cache.contains the character.name, then character.isVisible equals false. Let's make sure that they are invisible and not on the screen. All right, and with that, I think we're good. That just means we come back to the history state, and we'll go ahead and say that character data.apply and pass in all of our characters. And now we can capture a history state, and we should be able to reload it. So if we look at our history testing, H should capture a state, and R should reload it. So let's try that out. So I'm going to start by caching this state. Click H, and all we have is some audio. We got no characters, no graphics, and we've got some dialogue on the screen. Now let's proceed on through, and let's get to where we have some background music and characters. Okay, so now let's go and hit R. Okay, so it took us right back. Music stopped, backgrounds are gone, characters are gone, and we are back to this text on screen. So let's try to get back there. Oh, yeah, so that's an issue. But actually, it's not really an issue, because we're going to handle that in a different class for history traverser. So it'll maintain the progress, and it won't let us continue back where we were until we end our essentially our history viewing state. So let's go ahead and try a different point. I'm going to go back in here, and I'm going to go a little bit past that. We're going to skip, and we're going to go all the way in here, and I'm going to say H. So now I've got characters Stella, Raylene, I got the music, and I've got the background. So let's go on a little further, And let's go into the N. So we'll transition to a new scene. There we are. Alright, so now let's get the new character to come on screen. Here we are. So the innkeeper came in. Now I'm going to hit the R key. There. And we can see Stella, her expressions changed. I think Raylene's did too. The innkeeper's gone. We reverted back to the text. And everything looks pretty stinking good. I think we're good there. So that actually takes care of our saving and our loading of history states. So in the next video, we're going to work on navigating through the history states. So we'll cache them into a list using a history manager, and we'll be able to go backwards and forwards through that list and go back and see what we've done and what the decisions we've made and all the previous dialogue. So I'll see you guys in that episode.